Greetings everyone. So greetings and welcome back. And welcome to lesson 8. So we're still doing forces, okay? Contact and non-contact forces, okay? So today's lesson we're going to do question 4. Okay? Question 4 is from, okay, this is from Gauteng, okay? It's from Gauteng province. So okay, so let's read the question together. They say, study the pictures below and describe what visible effect a force can have on each object illustrated. So here we see a soccer player and he's kicking a ball. Okay. So the soccer player is kicking a ball for A. Okay. What is happening there? The effect of the force in this case will be what? So we go to 4.1. 4.1 A. And B. So if he's kicking a ball, okay, the ball is being kicked, so it can what? It can change direction. The effect here can be change direction. You can change the direction or change speed. So that is the effect that it can have here. And then for B, what's happening? For B, we have an arm, and the arm that is squashing a can here. Okay. So this is a squashing hand. So the effect that it can have here, it can change the shape. Change the shape of an object. So, okay. 4.2. 4.2, what are they saying here? That what? Students conduct an investigation to observe what happens to two charged objects before contact, during contact, and after contact, as shown below. One is positively charged and the other has no charge. Okay. So one is positively charged and the other has no charge. Okay. There's no charge here and this is positive. Okay, so they touch during contact, and then after contact, you can see that they both appear to have, there are positive charges around B all of a sudden. Okay? Now, 4.2.1, they say, what is the name of the force? What is the name of the force that exists between the charged objects? So here, the answer is going to be, I think I can do it here, electron, because they are charged objects. Okay, so it's going to be electrostatic force. Electrostatic force. What is the dependent variable in the investigation? Okay, what is the dependent variable in the investigation? So the dependent variable in this case, that's going to be the what? It's going to be the type of force. It's going to be the type of force that is observed between the objects. And then 4.2.3, which particles will be transferred from one sphere to another sphere when they are in contact? Right, only protons, neutrons, or electrons. I told you in lesson 1 that what is only electrons. Only electrons can be transferred because the neutrons and the protons are where they are at the center of the nucleus and they don't move. The electrons are outside the nucleus, so it is the electrons that can move from one object to another. So electrons are the only atomic particles that can move. Protons and neutrons do not move from one object to another. Okay. Sphere B was neutral before contact. Did it have charged particles? Write down yes. Write down only yes or no. So it's going to be yes here. Okay. Because remember what we said? We said that an object is neutral. What is neutral does not mean it doesn't have charges. What it means is that it has an equal amount of protons and electrons, isn't it? So that's what it means. It doesn't mean that it doesn't have a charge. So it does have charged particles, but the particles are equal. So they balance out each other to make the object neutral. You understand? So it does have charged particles, but they are equal to each other. So that's what makes it neutral. Okay, so 4.2.5 is on the next page. Okay, so let's do next here. Okay, yeah, here we have 4.2.5. It says what? Notice how the position of the spheres change after contact. Suggest a reason why the distance between the spheres is so much bigger than before. Okay. So the spheres carry the same charge. The same charge after contact. So they will repel each other. They will repel each other. They will repel each other. So that's why. Okay. Now, that's the reason here. So that's the answer here. So that's why the distance is so much bigger. Because it is far away here. During contact, there is a transfer of charges. So the electrons are being transferred here. And then after that, they repel each other. So that's why they go away from each other. So they repel or they push each other away. Repel just means to push each other away. Okay. 4.3, as it say, two magnets are placed so that their north poles are facing each other. Okay. Their north poles are facing each other. So 4.3.1, they say what? Is the force that the two magnets exert on each other a field force or a contact force? The magnet, that is an example. So they will exert magnetic forces on each other. And magnetic force, so it's a magnetic force. There will be a magnetic field here. Okay. So it is a field force. It is a field force. Okay. Number 2, 4.3.2. Draw the magnetic field line pattern that can be observed between the two north poles of these magnets in the space below. Okay, so the two north poles. So you remember what I said is that, so in this case, they are specific. Right? They want us to show between the two north poles. So remember what I said. I said the field lines go from north to south. Okay, so they go like this, from north to south. So now the field lines will be pointing from north to south like this. And the other thing is that what? The lines must not cross here. So the lines should not cross each other. They cross each other, they touch each other if you have attraction or if you have opposite poles here. That's when the lines will cross and join and touch each other. But in this case, they don't. Okay. then okay, so 4.4 is on the next page. So this is what we have for 4.4. The graph below shows how the magnetic force changes with the distance between two magnets. So we can see that when the distance increases, what happens to the force? The force is going down. See, it starts here and then it goes down like that as the distance becomes bigger. Okay. Now 4.4.1. So they're asking, what is the magnitude of the magnetic force exerted by one magnet on another when the distance between the magnets is 4 centimeters? So 4 centimeters is here, is 0.1 Newton. So they say, what conclusion can be reached based on the results on the graph? So what conclusion can we reach here based on the results on the graph? So what we see here is that um, so according to the graph there, like I said, when the distance gets bigger here, because when it's 2, it's something, it's above 0.2. When it's 4, it becomes 0.1. And then when it's 6 here, it's below 0.1. So as the distance becomes bigger, the force decreases. Okay. So what we see here is that force decreases as the distance between magnets increases. Define weight. So what is weight? Weight. So weight, okay, let me write it here since it's the last one. So weight is the force what is happening. Weight is the force exerted on the mass of a body by the gravitational field. Or alternatively, you can say what? We can say weight is the force with which it's is the force with which the Earth attracts is the force. So weight is the force with which the force attracts all objects towards its center. So these are the, so you can use the second definition or the first definition. It doesn't have to be both. Okay, you can choose one. You can choose this, or you can choose that. Okay. I don't understand what is happening with the theme today. It is acting funny. Yes, so guys, I think let's leave it here for today. Okay.